The idea of heaps is that we have a complete left justified binary tree where we have the invariant that every element is bigger than both of its children. So this element at the top, and this is called a max heap, which the max invariant states that the element at the top will be bigger than both of its children. So this element is bigger than this and this, and these two in turn will be bigger than their children, and so on. However, this does not ensure that every layer is bigger. So you may have contours like this. For example, you may have the element 10 over here, 9 over here, 8 and 7 over here, and 5 over here. This is perfectly fine that the lower elements may be bigger than an element higher up because they are not directly related, as 5 is not the parent of these elements. This allows us to have big of 1 searching for the biggest element, because you can always get the element at the top. To insert into a heap, we have to add an element over here at the bottom. Say for example, you add a new element. This element may be violating the inequality suggested over here. So if the child, the one we just added, is greater than its direct parent, we should swap the child and the parent. So say for example, the parent was 3 and we added the number 7 over here. We should swap 7 and 3. So now this would be removed and 3 would be written over here, and 3 would be removed and 7 would be written over here. However, we again realize that 7 violates this inequality. So we'd again swap these two numbers, put the 7 over here and put the 5 over here. Finally, the inequality between these two numbers, 10 and 7, is held. Therefore, we should stop the process of insertion. Therefore, every insertion will consist of creating a new node, joining it at the end of the binary tree, and keeping on swapping with the parent as long as the max heap property is violated.